I hope you guys are back from some tea and coffee break. Today's topic is CTAM, which stands for Compliance Tool for Accelerator Manageability. My name is Anish Gupta. I am from Nvidia. Along with me is Rajat from Microsoft and Venkat from Ramesh. Ramesh from Meta. This tool is developed by these three companies and contributions from AMD and Google. Why do we need this tool? This tool is developed for accelerator modules. They come in different sizes and shapes. Some are consumed as discrete GPUs and some as baseboards. So when you see this diverse portfolio of servers or how GPUs are consumed, when these get consumed in data centers, we wanted to ensure there's a consistent manageability story around firmware update, telemetry, and RAS. And for that reason, this compliance tool was developed. The tool benefits CSPs as they consume accelerator-based modules in their data centers during deployment or integration, as well as GPU vendors when they are shipping products. The tool uses Redfish APIs, and with keeping everything consistent, it makes it very easier or reduces the time to, or makes time to market faster of adopting the servers with GPUs in the data centers, and also enable scale. The tool adheres to OCP specifications, and then Rajat is going to go into details on those.
Anish? All right, so let's dive in a bit on the features of which the framework provides, okay? So like any other compliance tool, you have a framework and you have a bunch of compliance scenarios on top of it. One of the key features that we wanted this tool to adhere to was spec-based compliance. We wanted to make sure that we are very much aware that we have an ever-evolving spec at the GPU for the GPU accelerators. It's still it's currently at around 1.0. So we wanted to make sure that as and when we get those spec updates, they fall in as collaterals, and all the scenarios get we do a compliance testing against those collaterals. The other thing is, if you look at these compliance scenarios, they fall under different domains, be it firmware update, RAS, telemetry, and maybe future we'll have some more. And also, each of these compliance scenarios are unique. Some we believe would be more important than the other. So they would be tagged with a compliance level. And together, we can have some scoring schemes in place, which is again entirely optional though. The other thing is, we are very much aware that as and when users use this tool, you are inclined to put in more and more scenarios in it. You want to kindle that exploratory the love to find more and more issues and hence build more scenarios from it. So at the same time, you don't want to risk IP exposure, right? We do have a mechanism and documentation in place on how you can do this without risking any IP exposure. Also, it's quite common that you don't want to be running the entire compliance suite. Often, there are validation demands where you would want to be running just probably a subset, or maybe you want to order it differently, right? We understand all those, and hence we have baked in ability where you can define your own regression modes. Overall, we wanted this to double as a validation framework for the entire community, and that's how it's been designed. To continue on the features, now Anish did bring about the details about those design points, right, for the GPU accelerators. It was also covered earlier in the earlier topic today on the accelerator management specs. But nevertheless, there are going to be some differences in the connectivity models. The tool is designed to cater to those different connectivity models. And also, you could be having different platforms, works well for that. You could also be having different environments to invoke the compliance tool, and it caters to those as well. And a lot of you here, we had some wonderful talks also earlier on other validation. And we are take for example DMTF. Wonderful number of tools out there. You want to leverage the goodness of all of those, right? So we have again a mechanism and documentation in place on how you can easily integrate those open source tools, and that way you help build a rich compliance scenario set. if you look at any spec, right, they have a verbiage which will say some things are must, should, whereas there are other things that you say this is how you can do it, right? So for the ones which are must and should, within the community, we make those rules and we say, okay, this is exactly how the scenario is expected to behave. However, we have the other loosely defined areas where you could have the supplier define the flow in their own way. And for those, we can provide override modes, right? So this is something that the tool also provides. And finally, we are all debuggers here, right? We day-to-day, we not just find issues, but we also want to quickly get the resolution for them. So having a diverse set of logs and yet being able to have it easy for the eyes to see and debug is crucial for this tool. So that's one thing that's also been integrated into it. Overall, we want you all to be able to adopt this tool fast and fall in love with it. Digging more into the logging aspects, when you run the compliance tool, you have a report summary, you have all the OCPTV logs. Yes, this tool does use OCPTV diag course at the center, and you also get the logging in a similar format as what one of the previous presentations where they went through the sample OCPTV output. You also have redfish logs and many more logs. Like as I said, you can actually be invoking another tool, and those tools would have their own logs. So we make sure that all of that is available and they're all interpreted. Now, what you see here is a sample output of what a compliance run looks like. But quite often, as an engineer, we also end up having to up-level this to management, each organization, each of us have different needs and different ways in which we want to up-level it. A simple way to up-level would be if you want to just say that, okay, I have a full good compliance pass versus I've got a 60% pass, right? As against, you may want to up-level it saying that, oh, firmware update domain is good, but telemetry domain needs to do better, something like that, right? So you could potentially have a report that will cater to that need as well. Or you could get fancy. We have ways in which we can weight, as I mentioned before, we have an organic scoring scheme. So we can actually weight the compliance scenarios based on their importance. And you will then be able to generate a weighted score which can be used by you. The sample set of logs that get generated, which cover the report summary, the OCPTV logs, the redfish logs, the other tool logs. So yeah, these are the features. Over to Venkat to provide more details.
Thanks, Rajat. So Rajat spoke about some of the features that actually he built a lot into the tool. Now, I want to talk about some of the wins that this tool has already enabled through these features for both suppliers and hyperscalers. Any compliance tool, one of the job functions it serves is to make the specs more actionable. So this CTAM tool provides a test-driven approach to kind of measuring what the requirements are, and gives us a way to feedback into making the spec more clear, right? Like we saw some examples of this in the RAS spec, where as we were trying to develop test cases, we had to go back to the spec developers and ask questions about what the intended the use case was. The other thing is, with the scoring scheme, we now have a common quantifiable way of measuring our own compliance, because on day zero, we're not going to be compliant to the spec, right? There's always a eventual path to adoption, and the CTAM tool provides that eventual path to adoption because it gives you a way of saying, this is my score, and this is how compliant I am, and this is my target. And for the suppliers especially, this is crucial because not only do you have a score, but it also gives you compliance levels and there's weightage, right? Like so, suppliers can prioritize in which generation how much of the compliance they want to meet, and we can have a conversation with the hyperscalers. Finally, I think Rajat spoke about the OCPT and V logs and the variety of logs that are available. CTAM serves a purpose as a regression tool, right? Like, so in the earlier talk, Jan and Vineet spoke about AutoVal, right? Like, so internally, AutoVal is our validation framework, and we wrap CTAM inside AutoVal, and they both use the OCP TNV format. So in the next talk, you'll see how having a family of diags that speak the same language enables us to have a comprehensive regression suite for measuring firmware regressions and keeping track of NPI progress. So CTAM has brought architecture, design, and validation engineers to the same table through a very concrete and measurable way. Now, as this tool matures beyond the initial audience and goes out to more people, there's some of the things that we're working on to make the tool easily usable by a large set of audience. One of the things we're investing heavily in is the release process and kind of the unit test coverage, and also the GitHub actions to trigger, say, on a pull request and a release to a PyPy, so it becomes easy to adopt for different use cases, makes merging features easier and stuff. We're also looking at ways to make CTAM tool work with the Redfish mockup server, so you can also kind of run pre-hardware availability kind of tests. And in terms of the test itself, a lot of the investment that's going on and the discussions are around the RAS, the RAS spec test cases, but we're also looking at enhancing the Redfish telemetry and the event service compliance scenarios. Finally, I think as Anish mentioned, there are two models, and we are primarily heavily biased towards the GPU UBB model, and a discrete accelerator use case is something that the tool will actually support going forward in a big way. And also, especially again for the RAS spec, out-of-band scenarios are only part of the picture. There are a lot of in-band scenarios that also need to be part of the tool, and we're looking into that because right now the tool is also heavily leveraging Redfish and out-of-band. So what is the call to action from you all? Obviously, I think a lot of people here in the last 2 days, like different tracks, alluded to this tool. So even for the limited audience who are privy to this tool is actually serving a lot of purpose. So we'd encourage all of you to try it out. Go to the GitHub link, sign up as a contributor, try and give us feedback on GitHub discussions. And apart from just investing in CTAM, if you have ideas about how other tools like the Redfish interoperability profile is one of the things that's actually the hardware management for management group developed, and it's now we actually build a test scenario in CTAM for that. So if you have ideas on how we can leverage a lot of the open source tools in CTAM, we're happy to hear that. Again, like I said, it's a feedback loop between the tool and the spec. So please use the tool to poke at and provide feedback on the spec. Right now, we've linked to the 0.9 version of the management interface spec and the various specs, the pillars that you was mentioned. It's again, this is probably the closing talk of the overall OCP GPU requirements workstream that you heard. Has a lot of collaboration from AMD, Google, Meta, Microsoft, and Nvidia. And finally, I think you are also in a callback to the hardware management OCP GPU profile. We encourage you to kind of go poke at it and see, also contribute to the interop profile as well. So yeah, thank you. Thanks, everyone.
I think we have time for questions. Anyone? All right. Great. Thank you for your time. Appreciate it.